Hi there, welcome back. Welcome to another video in the Telefunken Dacapo series. And as is obvious, she's looking quite different. She's had her face made up, knobs cleaned, looking pretty spiffy, if I say so myself. Now, fortunately, everything was in perfect condition. Nothing was broken. So what it involved was basically a lot of scrubbing, washing, drying, and so on and so forth. As is obvious, this work has got to start with a lot of alcohol. Isopropyl alcohol to be more precise. And then we've got to start cleaning the knobs. Now, various ways of doing it. One of the methods I use is a cotton swab just with the isopropyl. And you just keep going, make sure you get everything nice and clean. Sides, front, back, everything. The back, usually the top, the actual knob gets a bit darker because there's a lot of dust and soot and everything else accumulated on there. So you have to make sure you clean that as well. And this is just the alcohol at this stage. So I don't go into any fancy stuff. And basically the way you do it is you just keep carrying on, one little bit at a time. Lots of cotton swabs get used, quite a bit of alcohol, none of it drunk. And yeah, that's how you do it. And then there's another method, and that is using a natural fiber brush, which is a little bit rougher than the usual synthetic ones. This thing also works quite well, and usually you can get away with this. If you can't, then you've got to revert back to the cotton swabs. But yeah, okay, again, same story. You just keep rubbing away. And once you've finished with the brush, you again get the cotton swab out and come and try and get a little bit more of the cleaning done. There's always a little bit left over. Watch that swab, it's black. So yeah, you can't just do the brush. You've got to get the dirt off. The brush just loosens it, and the cotton swab then gets rid of the dirt itself. And then, of course, you're sitting with some knobs that have got this alcohol on it, which is very, very dry. So what I like to do is just a little bit of WD-40 just to moisten it. Somebody actually mentioned recently that the knobs can actually crack if you just do it with alcohol. I believe it probably would. So I do a little bit of cleaning just with a very light coat of WD-40. You apply it and then you just keep drying and cleaning it off. And it usually comes out beautifully. And here's the result. Not bad. These knobs have actually got a grain on them, which is really, really nice. And of course, the knobs need to be cleaned as well. They're a bit of a mess. And the faceplate, which, as I said, fortunately is not broken. So yeah, let's look at the before. And then, of course, we get to see the after. Not bad at all. Everything cleaned up very, very well. Looking good. And before going any further, I just want to thank the sponsor of this video, PCBWay. Once again, whatever you want, whether you want the simplest solution for some prototype PCBs, 10 pieces for $5, or whether you want to go all out and do a full all-in-one solution, including 3D printing, board design, you name it, they've got it. Go to their website, check them out, and see how they can help you. Right, it's about time to do the RF alignment, and I'm going to start with the AM RF alignment, which means the medium wave, and then I'll do the long wave, and then we'll see how we get along, and maybe go and finish the FM one as well. Now, the part that relates to the RF alignment is shown on this page here, and basically what they do is they divide this up into two sections. One is the oscillator section, and the other one is the front end section. So, oscillator over there, and here is Vorkreis, which I believe is front end coils. So, and this is the IF trap, which we normally don't really worry about because they normally have not been tampered with. So let's start here. If we look at the oscillator for medium wave, they give us two frequencies, 1450 and 600 kilohertz. And they tell us to feed a signal onto the grid of ECH81. I'm not going to do that. I'm actually going to put it in with a dummy antenna, which is what they tell us to do down here. Over 100 ohm and 200 puff to the antenna. I'm going to put both straight into the antenna because I have a dummy antenna. And then I need, let's go back up to here. So we set it to 1450 and we adjust E. Then we set it to 600 and we adjust 14. And then we set it to back up to 1450. And we go back and readjust E. And sometimes you have to, flip backwards and forwards between these two a few times. And the idea is that you are hearing the signal or seeing the signal, whatever way you want to do it, and peak it, which means you use a meter on the output. Now, in this particular case, I'm not going to use a meter. I'm going to use the scope, or you can actually just use your ears, quite frankly. And the reason is that I tried putting a meter on the output, but because the noise is actually louder than the signal, I'm using a very low value signal. When it goes off signal, it actually goes, the voltmeter actually goes higher because it's hearing the hiss. So I'll show you when I set that up. So the first thing we do is set it to 1450 and we have to adjust E. This drawing gives us the switching arrangement, the top end of it. And the way to orient yourself is to look at where this one is. I'll show you that when I look at the overhead cam. And then we've got E over here and we've got 14 over here. Now, E is a capacitor and 14 is a coil. And how do I know that? Well, I know that because if I go to the schematic, here it is here. So E is the trimmer cap and 14 is a coil. And what we notice is that all the coils have numbers and all the trimmer caps have letters. Where's another one here somewhere? Never mind. That is the case. The trimmers have letters and the coils have numbers. So we know which ones to adjust. And let's see what they look like on the actual radio. Now, if we look at the switching arrangement over here, the way to get the orientation right is there's a 12 on the bottom left. That's 12 over there. That's a coil. And then your E is over here. That's the adjustment of the oscillator at the high frequency end, so at 1450 kilohertz. And that there is for the 600 kilohertz. So that is E, and that's 14. So we're going to set it at 1450, and we'll start there. But there's a little trick over here. There's a little bit of a problem. In that intro, I asked a question at the end, and that is, did you notice anything strange? Yeah, I fell for one of the oldest tricks in the book. When I washed the faceplate, I realized the back is covered it's painted, okay? So all the decals are on there, but they're painted through the back. And normally you can wash those quite comfortably. There is one exception. Where you can see through the dial, which is those lines over there, there are actually the numbers on there, and they are decals. And before I knew it, they were gone. So I washed off the decals, even though the majority of the decal was not washable. Now, I've done this so many times. A couple of times in the beginning this happened. It never happened again, and I got careless. And this just shows you, doesn't matter how much experience you've got, you can mess up, and I did. But it's correctable. I've got some decal paper. I've got photographs of this, not a problem. And also there's one advantage, and that is these guys have actually got little markers on there. Where is it? Medium wave. That's medium wave over there. On 600, there's a little marker just on the gold. Can't really see it too well, but it's there. And at 1450, there's another marker here. And you can just see that perhaps. If you look over here, just where actually let me get the dial. See where the dial is? Coming down, there's a little blip on the gold. Now those little black dots are the ones I've painted in, judging from the photographs. Don't worry about that. But we've got blips on there and on there, so we don't have a problem as to finding the places to align them to, which is great, because that would have been a bummer. And I want to get this done. I can always do the decals afterwards. But Yeah, time to get moving. So the first one is actually over here where it is now. That's 1450. And what we're going to do is send the signal and see if we get anything there. The signal generator is producing a signal, a carrier at 1450. This thing is, yeah, it's a 20 millivolts, but I can drop it and probably will because I'm not sure what amplitude I need on here. I've got a modulated signal on here. It's AM modulation and depth of 30% and an audio frequency of 1 kilohertz. So that's on. So I can send this off. It's coming here into the switch attenuator, and I can switch 3, 6, 9, and what is it? 24 dB. 3, 6, 12, 24 dB. I can switch the attenuation as much as I need. At the moment, there's nothing there. The bottom switch is actually for a dummy antenna, and I've got that activated. So this makes the signal generator look like an antenna to the radio. And then the signal comes out of here, and it's going into the ground and the antenna input. So we're all set, ready to go. Right, so I have the signal coming in, and I've got the volume going up now. And all I hear is noise, so my signal is not there. Not going to put the volume that far up. I'm going to just tune away a little bit. There we go. And we are just slightly off. We're about 1 millimeter off. So what I'm going to do is put it back at 1450. Okay. We can put this on dummy load so we don't have to hear it. And now I'm going to adjust this guy over here. See which way I need to. Oh, there we go. There we go. That is as good as it gets. Put the volume up, or the sound on. And if I look now, I'm right at 1450. Brilliant. Volume down. I'll now do the next one for 600 kilohertz. So we'll set this guy to 600 kilohertz. Everything stays the same. And now we need to do this guy over here. Now this is all full of wax. Actually, before I do that, let me see where it is. I might not even need to do anything. So I'll tune down to 600. Ha! This thing is exactly on 600. Brilliant. I don't need to clean the wax off that and adjust it. It's perfect. Perfect. Okay, that is the oscillator adjustment for medium wave. So let me pause for a second and see what we need to do next. The next thing they tell us to do is to set this thing at, I believe it's 160. No, it's at 200 kilohertz. Put it on long wave and adjust it for 600 kilohertz, 200 kilohertz. So let's put this on 200 first. So 200 kilohertz. Everything else stays the same. And the one we need to adjust is 15, so it's that guy over there. So we need to put it on long wave, which is that guy there. Put the volume up a bit. And go to 200. Now where's 200? I'm hoping there's a little notch here as well. Well, let's see where it is first. Yeah, there is a notch right over there. Put the volume down. Now if we look really closely on the long wave, there is a little notch there. You can just see it. When I dial in, that from where I'm standing is perfectly aligned, so I don't need to do anything there. So that was it. That's long wave aligned. Not bad at all, even without the bloody readings on the dial. Who needs readings, eh? Okay, let's have a look at the front end. Now the front end, slightly different. For medium wave, they tell us to, again we've got 1450 and 600. And 1450, the signal's going into the antenna, which it already is. And we align D. At 600, we align 4, and then we go back to 1450 and check for D. 4 is actually on the ferrite antenna, and I'm loath to mess with that because those are usually pretty good. So I'll check what it's like on 1450, and I need to adjust D. Now, which one is D? That was E, and D is opposite 14, so it'll be a capacitor again, okay? So let's set that up, 1450. So we're back to 1450 kilohertz. Okay. Put it on medium wave. Put the volume up a little bit. See if we've got anything at 1450. There we go. And now we need to adjust D for a peak. So I'm going to put the volume up a little bit there. Oi, that's too noisy. I'm going to put the switch to dummy load. Now that gets a little bit difficult to determine if that's peaking or not. So I'm going to try something. Let's see. If I do acquire and I do averaging, not very good, is it? It's a bit better. Yeah, I guess it's a bit better. Let's see, I can do this as 4, 16, that'll have to do. Okay, so I need to peak this guy here for a max. I think I'll actually prefer the audio on that. And I can probably sort of judge the two. This thing is a capacitor and it's stuck with glue, with paint. So you can take a screwdriver there and just chip the paint, just give it a little, just till it moves. And now you can use this, which is a non-metal screwdriver. Well, that made a difference. It's going down. Going down. That's about a peak. That actually made quite a difference. So the front end was not as well tuned as I would have liked. Okay, and for long wave, they say you've got to adjust 15. No? What is it? 9. Which one is 9? 9 is this guy over here. And that's a bummer. You've got to put it on 200 again. So we'll adjust that 200 kilohertz, put it on long wave, put the volume up, go to 200. Oi. Okay, let's not have to listen to that. And we've got to peak this guy over here. Now this guy is a strange one. This one you actually need one of those hex screwdrivers. And the problem with that is I've only got metal ones. I may be able to do it with a metal one, but I'm not sure that it's going to affect it. So let me see. It doesn't. Okay, that's good. Let's see if we can get anything out of there. Absolutely no difference that I can see. This might be the fact that the signal might be too high, so I'm going to attenuate it a bit. And in fact, I'm going to take off the averaging, because that's stable enough. And let's see if that goes up at all. That's making no difference. Okay, well, if it doesn't, it doesn't. Oh, there's one thing I need to check quickly, and that is to see whether on 600 it's picking up on 600. So let's just quickly do that. So because I don't want to mess with that coil on there, it's stuck on there with a lot of wax, and I mean, usually this thing is perfectly fine. I'm not going to mess with that. The 600 is picking up actually stronger than the 1450, as we noticed, with the same signal, same amplitude. When we got to 600, the amplitude was higher, if I remember correctly. So I think that is pretty much peaked, and this means that our RF alignment for the AM bands is done, and we got a bit of an improvement on the 1450. And it was pretty simple. Now, the only complication was I have no dial indicators here, as I mentioned, because of my own stupidity. And some of those knobs on there, some of the coils on there have got that hex positive. So you need a hex negative. You need something like this in plastic, which I don't have. But it seems to have worked pretty well, which means we're okay. Good. And so I'm going to end this video here for now. I'm going to just do a little bit of checking on the FM alignment, because the FM alignment is a bit strange. I'll tell you what they tell us to do. They actually specifically mention that you should not mess with the oscillator, the front end coil, and so on, okay? They tell us that we should not mess with that. In other words, they're telling us that we cannot adjust the oscillator. What they tell you to do, put it on FM, send a signal at 94.5 from a signal generator, then go to 94.5, which is, here, right? There's 94.5, and you should catch it on there. You should get it on there. And if you don't, what they tell you to do is to move the pointer, physically move the pointer. So what you need to do is you need to grab the pointer over there, and you can actually shift it along the dial cord, and they tell you that if it's not exactly at 94.5, you force it to be. So let's say your signal is being transmitted at 94.5 and you're picking it up here. You need it to be there. You go onto the inside and you literally pull the pointer, slide the pointer along the dial cord to here. And that's how you adjust your dial cord. And then, of course, what it means is that the circuit is designed to, from 94.5 to tune all the way to 100, so 5.5 megahertz, and tune all the way to 87.5 on the downward slope, which means they're telling you that the span is always the same, and you just basically you can't adjust anything. Now, that doesn't really do me much good as far as my goal is concerned. My goal is to get this thing to go to 101.6. So I need to think about why the circuit is so sensitive that they don't want you to mess with it, and if it's worth messing with, and probably will be, because one of the subscribers and a friend of mine has sent me a schematic for a different make, which is exactly the same circuit on the FM block, and it goes up to 100 and something. I think it goes to 104, he said. I'll have to check the email he sent me. So this does go up to there. I need to see what the differences are in the schematic between that one and this one, and see whether actually going to that oscillator coil is the best solution or not. Because it is reachable, and it is pointed out, you can get it. But I'm not sure that I want to risk it. I'll have to see. So I'm going to sign off for now. And once again, thank you for watching. If you've enjoyed this, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you're welcome to do so on Patreon. Once again, thanks for watching. Bye for now, and stay safe.